Unit 2, Lines and Angles, Lesson 2.4, Congruent Angles. Please note the location and time that you're watching this video, and don't forget to get a parent, guardian, and teacher sign-off. Let's review. Angles JK and L are an LKM or a linear pair. JKL is 5x and LKM is 14x minus 10. Find everything possible. So we have two angles, JKL and LKM. Look very carefully. KL is repeated. That means it's going to be a spine, and they're a linear pair, which is a line, two angles that share a line and make a spine. So let's start by making a line and a spine. That is a linear pair. Now we have JKL, LKM. Notice the K and L's are repeated. That means that's your spine. So we have JKL. Then we have LKM. Share a spine, make a line. We are told that JKL is 5x, so J, trace and sweep, 5x. LKM, trace and sweep, is 14x minus 10. Find everything possible. Well, you should remember that the word linear pair means you have automatically 180 degrees. So I know that angle JKL plus our other angle LKM has to add up to 180 because it's a linear pair. So I bring down a nice circle plug chug. Now it's algebra, so you want to collect like terms and solve. We have 19x equals 190. So we divide both sides by 19. And we get x equals 19 goes in there once with the 0 left over, so x equals 10. Now you're not done when you solve for x. Notice that little sponge means find all possible items. So circle the x, circle the 10, plug it in. 5 times 10, that means this is 50. 14 times 10 is 140, minus 10 is 130. Now look, here's a nice little check, 130 and 50 does add up to 180. Check. Today we're going to talk about congruent angles. What makes angles congruent? Look out for these words: bisect, vertical, something called give and improve, complementary and supplementary. Once again, it would be extremely helpful if you have colored pens or pencils. Now imagine if you and your friends were having a pizza, and the pizza guy cut the pizza so that there's like one little tiny piece and one little big piece, and they try to serve it to you. You and your friends, most likely, if all the pieces were really uneven, you'd be fighting over the largest piece. Keeping angles congruent, or knowing what makes congruent angles, can actually keep the peace even when you're eating pizza. That all of these are equal angles. So what kind of things make equal angles? First off, let's review some key words here. says draw an example of each. We're going to draw a pair of adjacent angles. Adjacent angles means you share a spine. So there's your spine. If you have two angles that simply share a spine, these would be adjacent. If they're complementary and adjacent, complementary is 90 degrees. Adjacent means you have a spine. So there's two angles that share a spine and make 90 degrees. Vertical angles are made by two straight lines, think bow tie, and they're directly across from each other. And what you're going to learn today is they're also always going to be congruent. Those are vertical angles. They look like two little V's stuck back to back. Last one, linear pair means it makes a line. Supplementary, 180. So linear pair is share a spine, make a line. So here's your spine, and we make a line. We would say this angle and this angle are both a linear pair, and they add up to 180. That's a recap of our previous lesson. Today we're going to focus exclusively on congruent angles and what makes congruent angles. So there's a difference between adjacent angles and something that has an angle bisector. Here it says draw an angle PQR, underline that, with an interior ray QT. Circle Q. Q's your vertex. Ready? Let's try that. It says PQR, so Q's our vertex. PQR with an interior, so it's inside the angle, but we don't know where. So when we draw just an interior ray, it's really important you don't put it in the middle, so offset it. So in this case, interior ray QT would look something like this. It's offset from the middle, but it's inside the angle. That's an interior ray. They are adjacent. They're back to back. They share a spine, but they're not a bisector. So look at these two sentences. Notice they are exactly the same, except I swapped out the word interior and wrote bisector. Bisector means to cut exactly in half. So if we have an angle PQR again, Q's a vertex because it's in the middle, P, Q, and R, with a bisector. Bi means two, sect means cut in half. So we cut this angle right in half down the middle, and we call that QT. Now that's a bisector. There's a very important notation. Just like in a segment, if you have a midpoint, you've got to have hatch marks to prove to me that that is a midpoint. In an angle, if it's a bisector, you also must have this notation: sweep, hatch, sweep, hatch. That means that's equal. Those two angles are equal. Therefore, QT there is a bisector, goes right down the middle. Let's see if you understand this. I want you to finger track and read this sentence and attempt to draw it. Hit pause and come back. Okay, welcome back. Let's see how you did here. It says, draw an obtuse angle HIJ with an angle bisector IK. Trace and sweep HIK. Draw a bisector HIK and name the ray IL. A lot of words. Let's break it down. First off, we want an obtuse HIJ. So draw an obtuse angle bigger than 90. I must be the vertex or the hinge. H, I, and J. There's obtuse, there's HIJ. With an angle bisector IK, so starting at I, it bisects, we're going to cut this right in half, so go right down the middle, IK. Now in order for this to be a bisector, we must do this. Watch carefully. Sweep, hatch, sweep, hatch. That says IK is a bisector. Now, we're going to trace and sweep HIK. So trace and sweep. HIK, trace and sweep. And now we're going to draw a bisector of HIK with another ray called IL. So I, going through this red angle now, we have L. Now because it's a second bisector, notice this is the second reference to bisector, we have a second set of congruent angles. So sweep, sweep, double hatch, double hatch. If you caught those double hatches automatically, kudos for you, because I didn't tell you how to do that, that you used good instincts there. Okay, so let's recap what we know about congruent angles so far and adjacent angles. If you have an angle that does not have a bisector, but they are adjacent, so draw an angle here, draw adjacent, but not down the middle. So that's a no bisector adjacent angles. Now draw an angle with a bisector. Sweep, hatch, sweep, hatch. Let's ask ourselves, what can we do algebraically in this situation? Well, with two angles that are adjacent but not congruent, we can do this. We can say this angle plus that other angle equals the whole big angle. Little angle plus little angle equals big angle. That's if you don't have a bisector. You can at least add little angles to get the big one. If you have a bisector, we can say this, that angle is congruent or equal to this angle because of the bisector down the middle and the hatch marks. So notice the difference in the equations there. How does this play into word problems? Let's do one together. Read this out loud with me. Draw angle EFG with a bisecting ray FR. Measure EFG is 5x plus 3 and RFG is 10x minus 32. Trace and sweep the angles, no congruent marks, find everything possible. Let's take this one step at a time. We have an angle EFG with a bisector ray FR. So we draw EFG. F must be the vertex. E, F, and G. And notice that says bisect, so it does go through the middle, F to R. And if it says bisect, you have to do sweep, hatch, sweep, hatch. Now we are told that EF EF, this should read R here, EF and R, E, F, and R, trace and sweep, is 5x plus 3. And then we have R, F, and G is 10x minus 32. Find everything possible. The key to this is this word right here, bisect, which makes things congruent. So we have the second one on the right. We have angle equals angle. So we can set up our equation like this. Angle 5x plus 3 equals the other angle 10x minus 32. Now we solve. We have x equals 7. Don't get all happy just because you solve for x. It says find everything possible. So now we put 7 wherever there was x. 5 times 7 is 35, plus 3, this is 38. 10 times 7 is 70. 70 minus 32 is also 38. And then we can get this large angle by adding 38 and 38. And we get 76. So let's think about what makes angles congruent. These three are easy. If angles have equal measure, they're congruent. So it looks like this. If angles 1 and 2 are both 60 degrees, then I would say angle 1 is congruent to angle 2. Why? Because measure of angle 1 is 60, measure of angle 2 is 60. If you have equal measure, then they are congruent. That's one way angles can be equal. What if I do this? What if angle 1 is a right angle and angle 2 is a right angle? Well, since they're both 90, that kind of goes back to the equal measure. If you have right angles, they're automatically congruent as well. So angle 1 is congruent to angle 2 in this case. If they have equal measure, they're equal. If they're right, they're equal. Two more scenarios. If you have an angle that's bisected, you're going to end up with congruent angles. So start with an angle. Bisect it. Make sure you get the hatch marks. So in this diagram, angle 1 is congruent to angle 2 as well because of a bisector. Last one, if angles are vertical, then the angles are congruent. Vertical, remember, is made by two straight lines, so start by drawing two straight lines. And these angles directly across from each other are automatically congruent as well because they are what's called vertical angles. So in this case, angle 1 is also congruent to angle 2. Those are also called bow tie angles or cat whisker angles or whatever other illustration you can remember. Angles directly across from each other made by straight lines are called vertical. So take a look. Your goal is to memorize this page in the next 20 seconds. What are the 4 ways angles can be equal? 5. 5 ways angles can be equal. Try to memorize that. All right, you try. Hit pause and try to write out without flipping back those 5 ways angles can be congruent. They were, if angles have the same measure, then they are congruent. If angles are right, they are congruent. If an angle is bisected, it makes congruent angles. If angles are vertical, it makes congruent angles. That's 4. Where's the 5th one? Let's backtrack and talk about that 5th one. Last one that we missed here is if angles, there's something called transitive. Transitive. Then the angles are congruent. Now, transitive is a fancy word for something that is extremely common sense, so don't let that word put you off. It simply means this. If you have an angle 1 congruent to angle 2, so if you have an angle 1 congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. That's called the transitive property. How do you remember that? You transfer congruency from 1 to 2, 2 to 3, therefore 1 to 3. Therefore, the last one right here is transitive property. Let's see how we can wrap this up here. We're going to pull this all together with something called an explanation. So step number 1, follow with me. I'm going to read and then we're going to mark this step by step. It says, in the figure to the right, trace and sweep angle FCR and PCZ. Trace segment RZ and trace segment FP. So FCR, FCR, trace and sweep, and PCZ, PCZ, trace and sweep. Says trace segment RZ, so I trace it, RZ, and then trace segment FP, FP. I'm done with that, so I like to cross everything out. Now make note, what's a logical conclusion here? Those are vertical angles, so mark them equal. Next one. Angles FCR and PCZ are vertical angles. Mark appropriately. So FCR and PCZ are vertical. We're going to mark them. Vertical angles. Those are the bow tie angles, cat whisker angles. They're congruent. we're going to trace and sweep ACF, trace CR, ray CR bisects ACF, mark appropriately. So we trace angle ACF. So here's ACF, trace and sweep, trace CR, ray CR bisects ACF, so it cuts this angle in half. Notice this is the second thing that's cut in or congruent, so I have a set and sets. Now, I want you to think about this. Take a look at what's congruent up here. And it says, explain how you know, given this scenario, how do you know PCZ, that's this angle, in this situation, how do you know PCZ is going to be of equal measure to ACR here? Given this scenario, how do you know those two are going to be equal? I want you to take a moment. We're going to think about it and write it out. Now let's walk through what we know. We know that angle PCZ, that's this angle here, is congruent to angle RCF, that's this one here, because they're vertical angles. So this and this are equal because they're vertical, but the yellow. What else do we know? We also know that RCF angle is congruent to angle ACR because of the bisector. So these are equal because of the bisector. Now watch very, very carefully. Trace with me. Notice ACF is repeated. Can you RCF is repeated. So we have PZZ is equal to RCF, and RCF is equal to ACR. So finally we can connect the last one. We can say angle PCZ here is congruent to angle ACR here, which means these two up here, you can connect them now. There's no direct relationship between them, but what we've done is we've transferred congruency, so we write because of the transitive property. Remember I warned you, geometry is not just about how to do things, but why. So you're going to start being required to get the becauses in there. That's a very simple example of how that is used.